All right, so let's take a look. I'm gonna do a little bit of notes on a different sheet of paper. Well, you don't have to, you can do it. So if you take a look at our title today, we are solving equations with rational exponents. Oh, boy. Well, this sounds interesting. Okay, so let me just, oh, geez Louise. All right, so this is 7-5.
Oh my God.
All right.
Is there anything that happened in that show?
I
don't
remember it.
Okay, so I'm gonna give you some general rules and then we'll just practice a bunch because once you get the hang of it, it's really not so bad. So solving equations with rational exponents. Yeah, okay. So first thing we want to do is we want to get whatever is being raised to the exponent by itself. So let me just give you some how-tos. Step 1, get whatever is being raised to the power by itself. So maybe we could do an example problem as we work our way through this, like number, let's jump to number 9 real quick. So my example problem I'll do over here. It says 259 equals 3 plus x to the 4/3 power. Okay, so as we can see from this, the only thing that's being raised to the 4/3 power is x, right? So I want to get this by itself. I need to get rid of this. So what am I going to do? Yeah, let's just subtract 3 from both sides. So now I'm at 256 equals x to the 4/3 power. Sometimes step 1 will already be done for you. If it's not though, just do it. So get your exponent all by itself. So do you remember if it was something like 256 equals x squared? Didn't we just take the square root of both sides to undo the squaring? Right? Do you remember that? So basically, to undo a square, I square root. To undo a raising something to the 3rd, I would take a cube root. But here I'm raising something to the 4/3 power. So what do you think the opposite of that is? Kind of. I want to, because this is the cube root raised to the 4th. So we're actually going to raise it to the reciprocal power. What? Watch how cool this is. So there's step 2. Now I'm going to raise both sides to the reciprocal power. So watch this. Let me get a different color. I think the orange is a pretty good one. All right, first of all, what's reciprocal again?
Flip the fraction.
You flip the fraction. That's all reciprocal is, right? Fraction. Fraction flipped over. So what's the reciprocal of 4/3? 3/4. Watch this, everybody. I'm going to raise this to the 3/4 power. Now, whatever you do to one side, you have to do the other. So I have to raise this side to the 3/4 power as well. But look at what's going to happen on this right-hand side. What happens when you raise a power to a power? What am I actually doing with those exponents? Yeah, it's just one because you're multiplying them. 4/3 times 3/4 just becomes 12/12 or 1. Oh, do you see that? How cool is that? So on the right-hand side, this is literally just x now. And then on the left, all I have to do is figure out what is 256 to the 3/4 power.
Isn't it 4 root 256 exponent of 3, or did I do it backwards?
Say what you said again?
Like 256 root of 3 cubed.
Root 4, right? The denominator is the root you're going to take. I
Yeah.
think you said that right the first time.
I
The
think
fourth
I don't
root.
know. It's kind of hard to say.
The second time you said 3 2 times, but I think you meant, yes, what you said the first time I think was right. 4th root of 256, and then whatever that number is, now you're going to cube it. So if you still have this whole chapter, really, those little sheets are probably going to be handy. The charts that I gave you. So if you happen to have this. So I can look here and I can quickly see, let's see, 4th root of 256, yep, is 4. And then if I raise 4 to the 3rd power, that's just going to be 64. Right? Does everybody see that? So I'll write it here. So we're really doing the 4th root of 256. And then we will cube that answer. So what did we say it was? 64? And just like that, I'm done. So I guess step 3, once you raise both sides,
64.
Yeah.
because the 4th root of 256 is 4, and then 4 cubed.
What if you get like a rational?
So if it's not nice, then it would just stay as it is.
Okay.
So once we did raise both sides to the reciprocal power, then I would just say simplify and solve. Okay, let's try something like, actually, why don't you try number 12? So 12 looks like this, n to the 1/2 minus 4 equals 2. Everybody try that. We only have these 3 steps. Get the thing being raised to the exponent by itself. Raise both sides to that power. Simplify and solve. 12. Okay, you got an answer? Who's got an answer? Oh, come on. Jimmy.
I got down to n is equal to square root 6 squared.
If you square root, they should cancel each other out. You're close, but I think you've missed one thing. Zach?
36.
It should be 36. All right, let's go through our steps. Get whatever is being raised to the power by itself. So what's my very first step? I got to add 4 to the other side. I got to get that thing being raised to the exponent by itself. N to the 1/2 equals 6. Okay, Step 2 says raise both sides to the reciprocal power. What's the reciprocal of 1/2? 2. So in this case, I'm going to raise u to the second power and u to the second power. 6 squared gets me 36, right? What do I have now on the left-hand side? It's just n. When you raise a power to a power, you're multiplying those, right? So 1/2 times 2 is just 1, so it's n to the first or just n. Oh, look at that. Shall we try a trickier one? I knew you would want to. How about 15 is a good one. So 15 looks like this. 20 equals 10 plus b minus 4 to the 1/2. So who's being raised to the exponent in this? This whole chunk, b minus 4. So all of this I want to have by itself. So I got to get rid of this 10. So that's easy enough. Let's just minus 10 from both sides, right? Okay, easy peasy. So whatever is being raised to the exponent is now by itself. I'm raising this whole parenthesis to an exponent. And there's nothing else with that parenthesis. So I have done step 1 now. So now step 2 says raise both sides to the reciprocal power. So again, we have a 1/2, reciprocal of a 1/2 is just 2. So I'm going to raise this whole thing to the second power and this side too. Whatever you do to one side, you have to do to the other. So what's on the left-hand side now? 100. What's on the right-hand side? It's just b minus 4 now. The 1/2 and the 2 cancel each other out. So I just get b minus 4. So now this one's a little bit different because I don't have my answer yet, but I'm basically right there, right? All I got to do is add that 4 to the other side and I'll be done. By the way, don't forget, because math is awesome, you can take these answers and you can check them. If I take 104 and I pop it back in, 104 minus 4 is 100. 100 to the 1/2 power, remember that's the same thing as the square root. So it's just 10. 10 plus 10 is 20. Yes, that works. Ah, thanks, math, for being so kind. All right, let's do one more weird one. I'll have you try it and then, ooh. Should I have you do a really hard one?
No, 18.
Yeah, I'm thinking 18. Try it. You try it, and then we'll do it together. But everybody try it, and then we'll look at some of the ones where it's a root to start off with. Then we'll pretty much be done with this topic. Oh, this is a good one. Give it your best shot.
Yeah. That's
Well, step 1, get whatever is being raised to the power by itself. Actually, I wouldn't even do that. I would, honestly, if I'm trying this one, you can do that, but I would clear the fraction first.
Okay.
Just to make my life a little bit easier. So if you multiply everything by 64, it should be a little bit nicer to deal with. Bigger numbers, but so what? Less fractions. Anybody have an answer?
Yeah.
What's your answer?
2 times the cube root of 5 to the 4th, like all of that to the 4th equals x.
I have no idea, to be honest. All right, let's walk our way through this together. Any other answers? It should have just come out to be a number, I would think, but maybe not. All right, so let's try and make our life easier by multiplying everything by 64, just so we get rid of the fractions straight away. So that would give us 453. 64 times 7 is 448. And 64 times 5 is 320. Okay, so I'm here, a little bit better. I still need to get what is being raised to the exponent by itself. So let's minus the 448. So that's just 5, 20, x to the negative 3. All right, now, here's a very common mistake, is that right here, kids will stop and raise both sides to the reciprocal power. No, 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 my friend, step 1 is not done yet. The 320 is not being raised to the negative 3/2 power, only the x is. So we've got to get rid of that 320. So we're going to divide both sides by 320.
Oh, I got the wrong answer.
So now on the right-hand side, I have that all by itself. On the left, I can reduce 5 over 320 is 1 over 64. All right, now step 1 is done. Is everybody okay now? So step 2 now says, all right, raise both sides to the reciprocal power. What would my reciprocal be? Yeah, negative 2/3. So I'm going to raise this to the negative 2/3 power. And I'm going to raise this to the negative 2/3 power. So on the right, I'm just left with x, right? Because if you just multiply these two things together, you're going to get a positive 1. So I get x to the positive 1st power. Now on the left, take a minute and see if you can figure out what 1 over 64 to the negative 2/3 power is. You can. Let me give you a moment to see if you can figure it out before I tell you what you're doing. Jimmy? Oh, you're so close. It is. So a negative exponent doesn't make my number negative, right? What does a negative exponent tell me I'm doing in here? What do I have to do with this fraction if I have a negative exponent? Yeah, you're really flipping it, because remember, everything's going to get that negative exponent. So when something has a negative exponent, doesn't it move downstairs if it's upstairs? If it's down, it moves up. So if everything's going to get a negative exponent, everything's going to move. So it's basically just telling me, hey, take the reciprocal of this thing. So that takes care of the negative part. So now I really have 64, right? Because the reciprocal of 1 over 64 is just 64. Now raised to the positive 2/3 power. And then hopefully you remember, oh, okay, so that means take the cube root of 64 and then square it. Cube root of 64 is 4, 4 squared is 16. That is my answer. Ooh. Isn't that something? Huh? Yeah.
We're gonna be able to use the sheet.
Yeah. Even if I didn't give it to you, can't you just recreate it? You can, because all I did, look at all it is. I just was like, okay, what's 1 squared, 2 squared, 3 squared, 4 squared? Cube, same thing. Just cube each number. Fourths, just raise each one to the fourth. Because there may come a time when you don't have this sheet, but you can always just make it. Anywho. All right, let's try, not all of these. Some of these have roots to begin with. So let's try something like, oh, that one's a little bit too hard to start off with. Let's jump back to something like number 8. If your equation has roots instead of exponents, it's basically the same thing. So we are going to still get root alone. And then we are going to raise both sides to opposite power. You can still think about it as a reciprocal, but I mean, it is the same thing. We'll talk about that in a minute. And then solve. Okay, so I'm going to do something like number 8 right now. Ooh, actually 8's kind of a hard one to start off with. Actually, let's start with 10. We'll go back to 8. 8's much harder than 10, believe it or not. Okay, so this one has a root instead of being raised to an exponent. You could do that. You could just rewrite the cube root of a as a to the 1/3 power if you want to, and then do the same thing that you were. So if you'd rather exclusively deal in exponents, you could certainly do that. Or I still just want to get the root by itself. So let's add 7 to both sides. So I have a cube root of a. What should I raise both sides to cancel out that cube root? What cancels a cube root? Yeah, raising it to the 3rd power. Just like canceling out a square root, you square it. Canceling out a cube root, I'm going to cube it. So I'm going to raise both sides to the 3rd power. If you do 5 to the 3rd, that's 125, right? And then this whole right-hand side, the cube root cube, just cancels out and it's just an A. Don't forget, you can always check your answer. Take 125, pop it back in real fast. 5 minus 7 is in fact -2. Yes, okay. See, not so bad. All right, let's try a harder one. Let's go back to that number 8 and see how we would tackle something like that one. The reason why this one is trickier, you'll see in a second. All right, what should I do first? Say it again. Yeah, subtract the 5. I want to get the root by itself. So let's minus 5 from both sides. Now what do? I'm going to square both sides. The only way to undo a square root is to square both sides. So this side will get squared, but the left-hand side also needs to get squared. And this is where I'm really nervous. People are going to mess up. So everybody watch me for 1 second. The right-hand side, this one's easy. A square root being squared just cancels. So this whole side literally just turns into x plus 7, right? The left-hand side, it is not x squared plus 25. If that's what you're thinking it is. No, friends, that's a binomial being squared. You got to FOIL that thing out.
Oh,
Yes. The only time you can just push the exponent to everybody is if everything in here is all multiplication. It's not. So you have to do x minus 5 times x minus 5. Oh, please do not mess that up. Okay, because then you're going to get everything wrong after that. So in this case, looks like we end up having a quadratic to solve. So just like we used to do when we have a quadratic, let's set the whole thing equal to 0. Let's minus x and minus 7. How would you solve from here? Yes, let's hope that there are factors that add up. Are there?
yeah.
Yes. Oh, hooray. So therefore, my answers are yes. Now, it is imperative that you check these things because you need to make sure that they both actually work. Because it is very possible that you do all the math right, but when you go back and check it, it actually doesn't work. And let's check, right? So if I plug 9 back in, is 9 equal to the square root of 9 plus 7 plus 5? Is that true? 9 plus 7 is 16, square root of 16 is 4, 4 plus 5 really is 9. So 9 is a perfectly legitimate answer. Let's try 2, shall we? So 9 is fine. Is 2 equal to the square root of 2 plus 7 plus 5? Is that true? No, friends, it is not. So 2 is what we refer to as an extraneous solution. It is an answer that we got mathematically, correct, like we didn't mess up, but it does not work. So I can't actually list it as one of my answers. So it is imperative that we check. In fact, if you got room to sneak it in, you should sneak in a step 4. We should be doing this with our exponents too, because that could happen. I'm going to sneak it in there again. We should have been checking all of these. I've been a little lazy with them. All right, but especially if you get 2 answers, check them, because 2 does not actually work. All right, let's do one more together and then we'll be done. So anybody have a preference? Do you see one that looks, any of them on the whole paper?
19.
19? Okay, let's try 19.
No 20.
20? Did we do 20?
Yeah.
Oh, all right, yeah, let's do 20 for sure. So you all try it first. Everybody try number 20. get an answer, I'd love to hear it. Zach? 125,
160.
Yeah, 116.
116, 116, so I'm hearing things in the hundreds here. All right, let's give it a whirl here. So this one is an exponent one, whether it's an exponent or a root, it really doesn't matter. I just want to get that thing by itself. So in this case, I got a -6 first, so we'll start there. So that's going to be 3125, right? And then I've got m plus 9 to the 5/3 power. Okay, cool. So that thing is by itself. Step 2, I want to raise both sides to the 3/5 in this case. I want the reciprocal power. So I'll raise you to the 3/5 and you to the 3/5. Okay, on the right-hand side, that just becomes m plus 9. So it makes everything kind of nice. And then on the left, I'm really doing the 5th root of 3125. And then whatever that number is, I'm going to cube it. So very convenient if I have my little chart. I mean, the calculator would do it for you too, but on my chart, it's pretty easy, especially when the numbers are nice. The 5th root of 3125 is just 5. And then I just got to raise 5 to the 3rd power, so I get 125. So to get n by itself, just one more step, let's just minus that 9 over and I should have it. So 116 looks good. Don't forget to check it. 116 plus 9 is 125. Cube root is 5. 5 to the 5th is 3125 plus 6. Yep, 3131. Yes. Questions? No, everybody's all right? Okay, so I think I want to do the rest of them that we didn't do because the first bunch are super easy.
Wait, which ones did we do? Like, I only have enough such examples. I don't have the numbers.
I don't know. off
We
the top of my
did
head.
8, 9, 10, 12, 15, 18, 20.
All right, that sounds good. Anybody have any questions right now? You okay? This seems easy enough? All right, so give it a shot. Let me know if you get stuck. Ah! You need another little sheet there on the corner here. Yep.
How many of these are we doing again?
What?
How many of these are we doing again?
All the rest.
Okay.
Yep.
Wait, what are we doing?
You're gonna do all the problems that
Oh
we
my
did.
god. I'm sorry. No, I just got it right. Sorry.
All the ones that we haven't done, which is
Except
not
for that.
as many as you think. Lights on. You see?
Yeah.
Feels like you lie about that. But
No
all right.
lying, no lying in this classroom.
All the ones we did.